Have you ever paused to think about ordinary things? Those little details we often overlook. Consider the humble clock, for example. Its hands sweep around its face, always in that familiar direction. A direction we call clockwise. But why do they move this specific way? The journey to find this answer is vast. It is a story that begins billions of years ago, long before humans or even clocks existed. It starts with the birth of our solar system and the formation of our own planet, Earth. A swirling disk of gas and dust gradually coming together under gravity's pull. This cosmic beginning holds the first clue. It set the stage for everything that followed. The early Earth was a violent, chaotic place, a molten sphere constantly bombarded. Yet amidst this turmoil, order began to emerge. The planet started to cool and solidify. Heavy elements sank to its core while lighter materials rose to form the crust. This differentiation was crucial. It laid the groundwork for continents and oceans. This grand cosmic ballet is fascinating. It connects the largest scales of the universe to the smallest details of our daily lives. Even the direction a clock hand moves has its roots in these ancient events. Understanding this helps us see our place in the vast, interconnected web of existence. Let's explore this remarkable chain of events. Our planet Earth is not perfectly upright. It spins on an axis, like a top, but this axis is tilted by about 23.5 degrees. This tilt is likely the result of a colossal impact. A Mars-sized object may have struck the young Earth. This event would have been catastrophic. It reshaped our world profoundly and gave us our seasons and much more. This axial tilt had a profound effect. It influenced how sunlight strikes the Earth, leading to different climate zones. But it also played a role over geological time in the way our continents are arranged. The forces of planetary rotation and mantle convection combined with this tilt guided tectonic plate movement. Slowly, continents drifted and reformed. Over millions and millions of years, something interesting happened. A significant portion of Earth's landmass became concentrated in the Northern Hemisphere. There is more land north of the equator than there is to its south. This is not a perfect arrangement, of course, but the difference is noticeable. This geographical quirk would have major consequences. Think about it. More land means more space, more diverse environments on a larger scale for life to evolve and establish itself. It also meant that early human civilizations had particular landscapes to interact with. This distribution was a lottery of planetary mechanics, a chance outcome of cosmic collisions and physics. And it set the scene for the next part of our story. The greater land area in the Northern Hemisphere provided vast territories for early humans. These regions saw the rise of many ancient cultures. From Mesopotamia to Egypt, from Greece to China, these civilizations developed agriculture and built cities. They looked to the skies to understand their world. They needed to track seasons for farming and navigate across land and sea. This concentration of early advanced societies in the Northern Hemisphere was not mere coincidence. Larger, more connected land masses can foster the spread of ideas and technologies, and the challenges of their specific environments pushed them towards innovation and discovery. One of the key areas of advancement was the measurement and understanding of time. These northern cultures were pioneers in astronomy. They meticulously charted the stars and planets. They observed the annual journey of the sun, its changing position in the sky. This knowledge was power. It allowed for accurate calendars and predictions of important celestial events. This focus laid the foundation for modern science. It was in these Northern Hemisphere civilizations that the first sophisticated timekeeping devices emerged. Driven by practical needs and intellectual curiosity, they sought ways to divide the day and to bring order to their lives. The methods they developed were ingenious, and they were deeply influenced by what they could observe in their northern skies. One of the earliest and most widespread timekeeping tools was the simple yet elegant sundial. Developed and refined in the Northern Hemisphere, a sundial uses a gnomon, a vertical stick or plate, to cast a shadow from the sun. As the sun moves across the sky from east to west, as viewed from Earth, the shadow cast by the gnomon also moves. Crucially, in the Northern Hemisphere, when you face south to observe the sun's path, the shadow cast by a sundial's gnomon moves from left across the top to the right. Imagine the sun rising in the east, your left, reaching its peak at midday above and setting in the west, your right. This shadow movement is what we now call clockwise. When mechanical clocks were eventually invented, centuries later, also predominantly in the Northern Hemisphere, the designers needed a way for the hands to move. What was the most natural, intuitive direction? They chose to mimic the familiar motion, the one everyone knew from sundials, the shadow's daily sweep across the dial. Thus, the hands of mechanical clocks moved clockwise. It's a fascinating thought experiment to consider. What if advanced civilizations had first developed mechanical clocks in the Southern Hemisphere? Down there, if you face north to watch the sun, a sundial's shadow moves the opposite way, from right across the top to the left. Perhaps in that alternative history, our clocks would all tick counterclockwise. A simple observation with a cosmic tale behind it.